So, good afternoon to all the participants, and thank you for joining us today. I am Aditya Sharma from E2V Cloud's marketing team. E2V Cloud is an Indian-based accelerated cloud computing platform for all your computing needs. We hope you will enjoy this session and learn a lot from it. Today with us we have Mr. Stalin, data scientist at Wow Labz. Mr. Stalin is going to talk about today is are the strategies to deploy machine learning model in production in the most effective ways. Mr. Stalin will talk about common challenges faced while deploying machine learning models and how to best strategize to tackle those challenges. You can write your questions in the Q&A session during the session, and at the end of the webinar, sir will answer those questions. With that, let's move to you, sir.
All right. Hey everyone. Let's just take a step back. It's pretty weird that we have woken up and it's like it's 2023. So happy New Year, everyone. It's I mean it's weird because like 10 years ago or something, like AI was just this buzzword that was just coming up, and our ideas for AI was to like most of the news articles would say that the future would be to like solve cancer, self-driving cars, like product recommendation and things like that. And fast forward to now, like it's so weird that this is actually now true. Like all of this has actually happened. And I mean, yes, like most of our movies have promised us like hoverboards and all. I wish I had one. But it's a pretty amazing time we are living in right now. And AI, it has just taken the world by storm, and it has been a very close part of our life right now. So it's also like very mission critical as well. So it's not something that we are just like, oh, we're just like researching it now, and no, it's actually being implemented, it's actually being used. And with that comes, it's also scary as well, because there's the ethical side of things, and you want to know if your AI actually works. And and then there's this whole thing of like, okay, how do I use this, even though this much time has gone on, it still feels so new, like at least to me anyway. um so yeah, so it's a great time to be, it's a great time to be a part of machine learning. um Okay, let's get down to the topic. So, today we will be talking about, machine learning deployment, and more specific, it's not going to be technical, so if you're coming here to, and if you're expecting me to give you like a template, oh, do this, and, or do that, I'm not going to do that, because the problem is that every machine learning problem, unlike software engineering, it's very, very different. Like you really have to take a look at what's going on, and it's very unique. You can't have a one size fits all kind of solution. It's very dependent on the problem. So so any engineers out there, you might have, I don't know, like I've come across this issue a couple of times. Like what happened is that a team of data scientists would be there, and they'll say that, oh, I have this new model that I want to deploy, and and they need your help in deploying that, right? And they describe what the problem is, and okay, this is what we're doing them, and everything. And then I ask them like, okay, you give me a code, and I'll deploy it. And they give you this. um I don't know what the hell am I going to do with that. Like it's a Jupyter notebook, and this is probably one of the most frustrating things, because like what am I going to do with this, right? Like so this is kind of where things are like slightly trying slim, because there is this huge gap between data scientists and engineers. So today we are not going to look at the technical side of things. We are not going to talk about like Kubernetes, Docker, API, blah blah blah. It's so easy to get lost in this like deep rabbit hole. Okay, and what we keep forgetting is that the most important part of all of this is actually communication. You need to have proper communication. It's a key, that drives a successful machine learning deployment. Organization goes into a lot of tricks to get projects done, but they always forget this particular aspect, and it tends to break systems. So we are focused on so focused on like breaking down everything into like microservices and everything, but we don't take a second to understand why we are doing this, what exactly are we doing here. So ask these questions first. Like you don't want to work, we believe that okay, you should have like atomic teams, and these teams will have this responsibility and they'll only do that. And and it just goes on. So you'll have a team of data scientists, you'll have a team of machine learning engineers, and both of them do their own thing. That At least to me, that's not a good idea. When you're deploying machine learning systems, it has to be done collaboratively. So so this talk is going to be a little vague in nature, especially for us engineers who are like, very incredibly action oriented. Like we want to require steps or a recipe to follow. But what happens is that we often miss out what we are exactly cooking. So, hi everyone, I'm Stalin and I am a data scientist at Wow Labs. And let's get started. So, out of the gate, let's get rid of these definitions. All right. So what is model deployment? Model deployment is basically you take your existing machine learning model and put it into an existing production environment where it accepts an input and returns an output. So your trained machine learning model is going to be a small part of a huge ecosystem, and your system is going to comprise of your UI, your API backends, and a whole bunch of stuff that's happening in. And machine learning is going to be a very small part of that entire system. So the different methods of model deployment is one is, you can have one-off deployment. So it's just done in periodic basis. You train it when you need it. It's not continuous in nature. And one of the examples is image classification or object detection. You don't see YOLO, like, that's one of the famous object detection machine learning models. You don't see like the versions coming up way too quickly, right? Because these takes time to train, and in fact the frequency of the data changes is so less. So you don't have to be too worried about it, and these are probably one of the easiest ones because you're just deploying it, and some point of time you will manually train it, and when it is ready, you deploy it manually again. You don't have to put in a lot of thought and cost into this. Then you have the batch based deployment. Batch based deployment is basically, so this is most of the time happens in enterprises. So you have models which which predicts let's say it's suppose it will give you insights on revenue, or it drives business decisions, right? So you have to be up to date with that model. Now at the same time, your data frequency, frequency of changes on data, it's going to be periodic in nature. So majority of the time your machine learning model might be updated every quarterly, maybe even monthly, but it's not going to be something every day. So these updates are going to be in batches. So you get the data till a certain date, you train your model, you validate it, and then you deploy it. Then you wait for the next batch, and the process goes on. Real time is probably something that is happening in the edge. So real time are like they are pretty difficult, and you make predictions on like incoming data. You probably work on a stream of data. For example, fraud detection is a great example here. You also have health activity, health tracking machine learning models. So these are real time. So you always have to be up to date. You always have to collect all your data, you have to train them continuously. So it's the frequency of data is so high, the frequency, and henceforth the frequency of your machine learning models updates will also be high. So factors to be considered, so this is going back to one of those three deployments, and this basically have this as a question, as a checkbox for you. Question, answer this, and then you'll have an idea what needs to be done. So how frequent the predictions will be generated? Okay, it's like very frequently. Then you're probably real time. But if not that much, then you don't need to put in a lot of resources. Then how quickly are the results needed? Like, okay, how instantaneous the model has to run and give you back the results, right? And this can be a mix of your infrastructure and your model performance. Are the results, should it be generated by batches, or should it be returned for every single point? The decide the what's the decide as a service level agreement. What is the latency of the model? What should be the computing capabilities that the infrastructure need for to run this model? What are the operational costs on deploying this model and maintaining it as well? So these are the factors that you want to consider. And and this, and from here, starting with this is how you design your architecture. Now, why is it so hard to deploy machine learning models? the well, to put it very simply, data scientists work very differently from software engineers. Data scientists, you have data scientists from like very different fields. Okay, like majority of the data scientists are probably not even from computer science background. They are like from very different fields. So you're always going to have that gap, because as software engineers, we are trained to code in a certain way. It has to be like oops methodology, it has to be in this design, and we are like so focused on that stuff. Data scientists, they just want to get their work done. Okay, so it's just going to be a notebook, just a couple of import statements, and do this, do that. It's horrendous to look at when a software engineer looks at a data scientist code at times. So this is actually one of the main difficulties you have, this gap between these two factions, basically. And the other difficulties that you have is in terms of like, unlike normal software engine, like let's say a web application or something, you do have this continuous development cycle happening. Continuously, new updates come and you deploy it and everything. But for a machine learning, it just, the development cycle happens in like different areas, because machine learning is just one part of it. You have the software engineering side also, which continuously develops. The machine learning side continuously develops. The data continuously develops. So you have more changes in play here. So all of these little cogs tend to break at times, if your process is not properly streamlined. So let's take a look at a sample machine learning workflow. So typically how it's like, your business gives you requirements, you have a plan or design on how you're going to do this. Your data engineering team comes into play, gets all your data, brings in all your data. Data science is going to run experiments, train your model, optimize it, package and deploy it. We're going to monitor, and it's just going to happen like this in a cycle. What you're going to notice here is that the work never just ends with just the model. It's always a continuous process, like just like most software system. You can't do like, oh, I'm done with my model, I'm going to leave now. No, there's always something there. It's never finished, right? Just like all software systems, it just never ends. So there is just more engineering work than just the model, right? Because a lot of times that happens. Oh, the machine learning model is the best thing. Okay, that's what all matters. Like, here you go. Okay, and you have the kind of ego come into picture. But the problem is it's so small that the rest of the stuff out there requires more effort. So there's just more engineering work than just the model. So thing is, what we have to understand is machine learning is so small. Okay, and in fact it's this small dot. Okay, it's this small, and this is told very well in this paper that was written by Google. And this is about technical hidden technical depths in machine learning. And from here you can see how small the machine learning code is. And then you have this huge, there's just so much stuff that is surrounding it, right? And most of your efforts go in there. It's not about maintaining the machine learning model. It's about maintaining everything else around it. Getting your data, getting your features, verifying your data, all your, serving infrastructure, all of these things, like, this is where most of your time and effort goes into. So let's get a little bit into technical depth, because we want to understand what this is basically, and this is basically proof on why you shouldn't be just focusing on machine learning model, but on the entire infrastructure behind it. Because a lot of times we feel like, okay, machine learning model, that's a huge thing, everything else is it's not that important, but it's actually quite the contrary. So, what is technical debt? Technical debt is basically you being lazy. That's that's the shortest way to describe it, right? So, thing is like, you either create something fast or you do them right. Okay, and if you do them right, problem is it takes a longer time, and your sometimes your requirements just change by the time you get things right. And if you do it fast, the problem is you are probably missing out some really important stuff that you just didn't have time to do it. So so what happens is this debt keeps on increasing, and at one point of time, the bounty hunters are gonna come in asking for debt, right? So this is what technical debt is. This is how the analogy works. You try to do something very quickly, you tend to miss out on a couple of important parts. If you don't come back and pay off those debt, it's you're probably you're gonna go bankrupt basically. So that is basically what technical debt is. Now for machine learning, sorry, just got stuck. All right. Now for machine learning, the technical depth is more, because so you have your typical problems with normal coding. I mean, you're using Python. If you have like terrible coding practices, no tests or anything, well, that's your depth has increased by that much. But on top of that, you have these very specific machine learning issues, and this tends to be incredibly painful to work with. And the reason is that because so all your problems when it comes to coding, that is just between you and your team, right? That's just between you. So there's more control there. But when it comes to machine learning, because you're working on data which is reflected by the world keeps on changing, right? The world keeps on changing. It's not the same environment as before. You can't use a forecasting model that was like created 3 years ago, and you can't reuse that now, right? Because the data has changed. And when the data changes, you're gonna have like new issues come into place. You might not have data at times. At times, a particular feature that you were using for modeling, that's gone now. You don't have it. So you have these very specific machine learning issues that is part of the machine learning technical debt. So let's just go back to this picture once again. So this is like very nice, it's like a very straightforward flow chart, but in reality, it's just a mess. Okay, there's just so many tools, so many people working in it. And honestly, like I haven't, filled it enough. There's just so much more going on here. So one thing that you have to keep in mind is any tool you use, you shouldn't be forced to move the data to process, transform, etc., like from the beginning to the end, right? Because it makes it extremely difficult. And also, the more tools you have, it just becomes incredibly difficult to maintain security, data governance, and the data flow across the system. So you have this added complexity here when you have these, very different teams. So once again, this conflict between data engineers and data scientists are coming. And data engineers have their own language. Your business executives, they have their own language. Your data scientists have their own language. The engineers are deploying it, they have another language. One person talks about Docker images, the other one talks about TensorFlow, PyTorch, the other one talks about Databricks and SQL, the other one talks about, well, business stuff. So this becomes incredibly difficult, because you don't have a common language among any of these teams. Everyone uses very different tools. It's just such a mess. And then, there's a lot of cost involved with all of these tools, right? So this is one of the biggest problems you have in machine learning systems. So what does it mean, basically, all of this? Like, you have this hidden depth that in machine learning systems, that it compounds silently, and that can be just it just can be very dangerous, because it's a lot of maintenance. Like, it's basically, if I write crap today, I have to spend more time fixing my crap tomorrow. That's basically, the problem with depth. And when it comes to machine learning, this depth is actually difficult to detect, because it doesn't exist just in, it's not within your code, because it exists in your system level. Okay, not just within your code. You might have unit tests in place, but it's not enough. There's just going to be a whole lot more there. And in general, machine learning systems are complex in nature. And in fact, like I mentioned before, your external world affects your machine learning, right? And sometimes, and even the small, when you change something, it can change everything. Okay, you change anything, it changes everything. And that's kind of how, the one of the problems with machine learning. Let's say you are training our usual example, cats and dogs, classifying between cats and dogs. For some reason, it's not doing a great job on classifying dogs. You might, augment your data to, balance it out, or you might try to increase the weightage for dogs. But when that happens, there's like a downstream of changes that's happening that you are not fully aware of. And this is one of the problems with machine learning. So, so one a few of the typical causes of technical debt is, lack of tests. Please have unit tests, have system tests in place. It's majority of the times, data scientists, we just write it and we're done with it, because we are so focused on writing in Jupyter notebooks. I think it's fair to say that, most of them won't be writing tests as well. Unit test, system test, it's incredibly helpful. It's actually, it's not just helpful, it's a requirement. It should be a requirement. Don't focus on like coverage report. Coverage report is just a terrible metric. But make sure that whatever property of your machine learning model you're expecting it to be true, make sure all those properties are actually true, right? And make sure have tests, just have tests, all right. Dedicate one or two sprints properly for testing. That just it. I mean, this is a no-brainer, basically. Then another causes are system complexity. You have a lot. This system tends to have a lot of stuff in between. It just have a lot of components, and it can be really complex, right? You have a lot of dependencies. Okay, not just dependencies within different parts of the system, but dependencies inside your machine, inside your code as well. So you might be using scikit-learn and a TensorFlow and different versions. Problem is that your versions can, there might not be compatibility involved if it is not done correctly. Okay, or you might be using an older version of something, and it might have a couple of security issues. But the thing is, you can't upgrade it because your whole system depends on it. So dependencies and these entanglements are a big problem. Poor readability and documentation, yes, that's like a huge thing. Please write doc strings. Please write doc strings. It doesn't take that much time. Just explain what you're writing. It's not just useful for other developers, it's actually useful for you. I doubt if anyone who has written some code, and after they come back a week, I don't think they'll recognize that code anymore. So please give proper documentation and comments. Then there are certain these design anti-patterns, or some people call them code smells. And for Python, they have like very specific Pythonic way of writing things. So try to avoid code smells, sorry. And yes, deadline pressure is probably one of the main things why this is happening, because as executives are so busy on cranking up features rather than investing in a process. So that's one of the issues. Now, how to pay off this technical debt? Refactor your code, improve and update unit tests, eradicate all dead code. Just don't comment a code that you're not using. If you're not using, just remove it. Don't just comment it or keep it there. It's just ugly. All right. Reduce the dependencies, improve your documentation, and yes, logging and monitoring. I cannot stress this enough. Logging and monitoring tends to be one of those components we'll be like, oh, we'll do it some other day, right? Don't. At least have the most simplest form of logging. In fact, one of the things that so one thing that so we had different systems in place, and we were all planning on, oh, let's have a centralized logging mechanism, and use this, we'll use Datadog, and it just went on and on. But nothing was really happening. What I ended up doing was just using Loggeroo, and we just saved as text files into a particular share folder, sorry, a file share, and with a particular rotation, and that has been it has been a lifesaver so many times. Because we would have these logs, and they would like save it in a particular directory. It's so easy for us to know what the hell is happening. Okay, and till now didn't get the, it has been 2 years, we didn't get the central logging in place. We are still using these text files that is in this share, and we are continuously using that. So just do a simple logging mechanism at least as a beginning, and then you go with like more advanced, but have some kind of logging in place, because you need logging. You need to know what the hell is going on. Otherwise you'll be so busy on like finding where the issue is, okay, or trying to reproduce the error. Okay, have proper logging in place, have proper error codes and everything. It just makes your life much easier. That's all. Now, question is like, how do I explain this to a non-technical stakeholder? About technical debt. Because stakeholders, they want features. I want these features now, and I want these features, yesterday. This is so the problem is, we try to convince them, hey, like we get it, but we want to take some time to properly do this, but they're like, no, 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 we can't do that. And that problem with communication gap always exists between these two. So the best thing what we could try is have business oriented metrics. Business people love metrics. They like a number which says something, and that is why they are so obsessed with coverage reports and stuff, because it's the only way to convince them. So maybe try something with that. Try to explain how much impact does it make on a customer. And this is a very good point that you can use. And this is exactly why you need logging and monitoring to show exactly these kind of issues that that can come across. So now I was talking about how we should work and everything. So let's get into the organization structure, right? Your organization, how does that, how should your team be organized? um let's go back to this diagram, and again, now the question is, who owns what here, right? Like what part of the segments, like who owns what? And this is actually very difficult to solve. And so the problem is that you have all these different tools, okay, you have all these different teams, and there is this tiny layer where there has to be there is an overlap, right? And so the data engineering team has to talk to the data science team has to talk to data engineering team. Everyone has to talk to the MLOps team to so you need all of these different teams to talk to each other and always always stay connected. But majority of the time, this particular overlap, who's taking care of it? It is some non-technical manager. There's no point in there, because you don't want a party person, well, technically it's not a third party person, but you don't want an external person to be the man in between, right? You can go and talk, get together and work together. These teams are not meant to be like completely atomic in nature. There's a lot of overlap in here, right? So don't treat these teams differently. You need to, these people have to connect together. Then only you can actually get things. I'm not saying it's impossible to work completely atomically, but you need that. Otherwise, it's not gonna, it's always gonna have a lot of delays. Like data science will create a machine learning model, they have to wait for the MLOps team, and they have to get a request, and then they have to give it to them. And then, by the next time, when new data is coming, data science has to talk to the data engineering team has to talk to the business to get the new data. It's just a lot of work, right? But when you work together very closely, a lot of these issues, you're ready, you're always ready for the next step, right? So it's incredibly important to make sure that communication happens between all of these teams, right? And typically your teams, what you want in your organization, and you need to have these following skill set. One is your data scientist, one who does the machine learning, builds the models. Your data engineering team, who basically, either it's either a data engineers team, or you can have a separate one, also the MLOps team. But if you are a smaller company, or if you're just starting out, you can have hand it off to a data engineering team. The data engineering team will take care of your data. It will help you with productionizing your models. Then you have your product manager, who basically takes care of everything, your scrum, getting your requirements from the customers, your data issues, your metrics. They handle all of these stuffs. And your executive, they will manage these particular teams. Now, one of these problems that you have is that the data scientists, like I said before, they're not really software engineers. So there's always that, gap happening. And they mostly work in internal services like analytics and stuff. So they don't have a complete idea on the software development process. And so they're not connected to the operations or product teams. Data engineers, on the other time, either they don't exist. Okay, it's not data engineers, it's probably like pure software engineers. There is a distinction between data engineers and software engineers. Not all software engineers are data engineers, but all data engineers are software engineers. So either they don't exist, or they're not part of the software engineering team. They're just like a complete separate, this one. It's either a data scientist who has taken up the role of data. That doesn't work out very well. And they don't work closely with the data scientists, and maybe they don't even work closely with the operations as well. So, once again, you have that gap. Product managers, on the other hand, they have most experience in user experience, on your typical, web design, and, those kind of technologies. Not that much on, machine learning statistics. So they have limited experience in data as well. So there is a problem there. And then next you have executive, um, who it's more difficult here, because once again they don't have much experience in, either they don't have much experience in team like this, or it's yeah, it's difficult to explain this one. But yeah, you have these particular issues among these four, particular skill sets. So, your company is probably isn't organized for machine learning. So that is something you want to address first. And figuring out this ownership is hard. And oftentimes you want to deploy models collaboratively, right? And this is what I've been keep on repeating, communication is incredibly important. And so what we see here is that most of the problems doesn't turn out to be technology. It's not about should we use Kubernetes, should we use this cloud or that cloud. It's not about any of that. It's actually your company structure. Okay, the way your company structure determines how you produce your digital products. So, this is actually what Conway's law is. So, Conway's law is a great way for accessing how software products are made and how the companies that build them communicate. So as an architect, you are supposed to influence the companies. You have to communicate their, through visuals, conversations, facilitate user-driven goals. Companies don't include this diverse perspectives or communication. There's just it's just very atomic in nature. So you have these problems. So Conway's law is a great way for evaluating that and their products to see who has good communication and how others can improve. So, one of the biggest problem in organization is the way targets are being set up. And they are not very aligned with the technology. So one of the a lot of times the targets for managers will be like, the team, the bigger team you manage, the better you are. Or one of the targets that we were having was like, hey, you're supposed to be having this much this much, you're supposed to get this number, which makes no sense. So you have these, your targets and all, is not very aligned. So how should we start with the machine learning project? Very quick and simple. Create MVPs. Okay, have small deadlines. Don't like wait for a month and then come back, because just like software engineering, requirements change. It really depends on your users, how things work and stuff. So you really want to get things out quickly. You can have a production ready script. You can even have a notebook, but I am not a fan. Personally, I'm not a fan of this. I don't believe that you should be giving a notebook to the whoever is going to deploy. The data scientist must take role, ownership of that, because they know the code well, they know how to write it well. So creating a production ready notebook, I am not a fan, but it works, it actually does work. So you can try that out. First, try deploying with a simple infrastructure rather than going with extreme levels of like multi-scaling, Kira and all of that stuff. But unless you're actually have experience in doing all of that, and then you can well how it's gonna scale up, then that's fine, you can go. But otherwise, try do it with simple infrastructure. Start with small components and then build it up iteratively. Don't try to build the whole thing in one go, because it's just never going to be over. It's software never ends. It's a product that never ends. So pitfalls to avoid: get, like I said, machine learning model, get into production fast. Don't just wait for too long. Okay, because the thing is, you need to know if your machine learning model, you need to validate it, right? And validation isn't just about, is your test data getting high accuracy? That's not all it is. You need to know if users, if this is actually what they are expecting, if this is what they really want to use, right? So that is the kind of validation that you really need. So you bring it out there. Your product managers will get your feedback from the users, and then you iteratively update it. So if you wait too long, you're probably going to fail quickly. Don't spend too much time on data. Okay, it's never going to be enough, right? You had just so much vast amount of data, and you can't use that as an excuse. Oh, I didn't get my data, so I didn't create my machine learning model. That's not going to happen, right? Like your data is going to come in its own pace, right? So your machine learning model has to get updated. So you have to work with what you have and iteratively make it better and better and better. And once again, with communication, like in the beginning, you are not going to know what all data you have. But as you go along, you will realize, oh, I need this particular feature set. Okay, oh, we have this particular data that you can use. So with this communication, you can give your requirements, so this is what I want, and they can also declare like, oh, this is what we have, right? So it works like that. Don't spend too much time on modeling. Okay, making the metrics. We are so like, oh, I'm getting 99.98 percentage right now. I don't. You just don't know if this is actually what users want or not. So don't get obsessed with model and performance metrics. Invest in the process rather. So, I'm just gonna take 2 minutes break, because I've been talking too much. Does anyone have any questions till now? Okay, because we are now gonna get into a little bit more, complex stuff. So anyone has any questions, I'm happy to answer. Anyone? Hey, Ramanath. Oh, hey, Amdad. Hey, Amdad. So I'm guessing there are no open questions. So, and that's fine, because usually these are vague. concepts, and it's supposed to just something that you're supposed to give in the back of your mind. I was wondering how data sets impact machine learning deployment. So, so basically, your machine learning is nothing but everything is about data, right? Your machine learning is about data. So, if you do, like, let's say you have a machine learning model you want to build, okay, and you do not have, let's say, what do you say? You do. There's a particular feature that you need, okay, and that feature is incredibly important, but your data doesn't have that, right? So that's gonna be an issue. Okay. So that is one thing. And then your data sets, it grows over time. Okay. New features come into place. Okay. You're going to have very different, from very, very different sources, this data is going to come into place. So you have to transform it so that, your machine learning model can use it. So, there's a lot of effort in terms of data. And then you want to detect data drift also, because at a certain point, okay, your data has been telling a particular story, and after that point it's going to say something else. So you want to detect these data drifts, and you want to make sure that your machine learning model is ready for those kind of changes. So that's how data sets impact machine learning deployment. Data is actually everything. So your data has a huge impact on it. One of the offshore teams is communication, especially with business. How do you communicate? Doing something right is better than doing something fast. Oh man, that's a like if you figure it out, let me know. Because it's a struggle, because the problem is the problem is it's a battle between the two, right? Like we cannot go and say that, hey, what we are doing is right. Okay, I can't, like what do you say, just go ahead and be like, okay, we are going to invest in a process, we are going to take a lot of months of time to design our system and everything. The problem is you're going to spend so much time on working on creating a design and everything that you're not getting a product out. You need to get a product out. So you need to get that tug, that pull from the executives, from your product manager. Hey, get your system out there. Okay, they are the one, because once again, you need to get your systems out into production very quickly. If not, you're just going to be you just have a model which is just going to stay in your computer. That is it. So it's a balance between these two, right? It's a constant balance. And one of the things to convince them is to, like, uh, you know, like, give metrics, give a lot of metrics. Okay, see, this is what people want. Okay, and you see that the number of issues we are having, it is so high. We are having so many alerts. We are always on overdrive. Okay, so if we can work on a system to fix this, it'll be great. Okay, it'll be really great. And in fact, this is actually one of the problems that we have. So we also have like a microservice architecture. We have so many components in place. Okay, the problem is we did not have enough time, because we were not given enough time to set up our local testing infrastructure. Like, we couldn't test things in local. Okay, we would do some change, we had to deploy it into a develop sandbox, and then, like, test everything. Does it work? If it doesn't, if it fails, again we'll deploy. The problem is because we did not have enough time to set up even a basic local setup, okay, to get things done. Okay, so we would have like 10-15 configuration with so many connection strings and everything. So it's important to have a process in place, but it is so easy to get lost in that process also. So you need both of these people. You need the business people to tell you, what the hell are you doing? I need this now. And at the same time, you also need to convince them, we will get it done. Just calm down. Okay, we are trying to get it done right. And it's always this tug of war. You need this tug of war. Okay, so yeah, that's how it is, sadly. Um, how do you tighten the APIs talking to different systems? It's not an easy question to answer. It really depends on your requirements. I'm afraid, like, you can't just say, oh, how do you just tighten the APIs? Like, uh, well, if you really want to tighten all your APIs, there you go. You have a monolith. You have a monolith. And, that's exactly what you don't need, right? So it's tough. It depends on your requirements. What really you need is to, have proper communication play, realize what services are independent of each other, and we'll get to that. That's what the next segment is. uh, my team is yeah, yeah. Good luck, Ambad. You build a appreciation for computer engineering, but I think way to get better idea. Yes, completely agree, Kaushik. It is getting so complex. And do you think there's scope to have a holistic solution? I didn't fully understand that. Can you make it more detailed? How is machine learning different from AI? So AI is like a umbrella. So AI is just now you have so many things, deep learning, machine learning, big data, all of these comes under AI. It's a huge umbrella. Okay. What we are currently doing is actually machine learning. I don't like calling it AI. AI is a little bit more, it is a little bit more about there is actual intelligence in AI. Machine learning, not so much. Machine learning is about solving problems which is very difficult. Like, let's say if you could solve image classification by just pure if and else statements, you would do that. Okay, you would actually do that. But the problem is it's so difficult for us to comprehend. That is why we are going into machine learning, right? That's why we are going there. So AI is a little bit, it's an upper umbrella. But once again, because of the hype train, all of these terms are being mixed and used in very different ways. So it's so difficult to, we don't know now. It has changed by in so many ways. Um, Okay, so I'm gonna get back. I know a few more questions are there. I'm gonna get back to this after the end. All right. Cool. Thanks, everyone. So let's get back to microservices, because majority of the time, when you're deploying things and you're creating architecture, it's gonna be a microservice. Obviously, everyone is doing it. We also gotta do it. Yeah, right. Um, so microservices, it's an architecture. It enables rapid, frequent, and reliable delivery of large, complex applications, and it allows your organization to evolve in its technology stack. So microservices, and this is a great definition by Martin Fowler. Just take a look at his talks. It's just amazing. Microservice architecture style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with the lightweight mechanics, often an API. So this is what a microservice is, creating small service. This is the problem with microservice. So now most of the time you're going to hear people say, oh, deploy everything microservices are great, and make everything like that. It's so much fun to just jump into, into this bandwagon without fully understanding it. And if you don't fully understand this, you're going to make very expensive mistakes, right? It's microservice is not for everyone. All right, you need to see if this is something that you actually need, rather than just picking up, oh, everyone is doing it, so this is best practice, just go with that. Okay, so this goes back to things, ship things quickly in weeks, because microservice, if you're a small team, you probably can't, you can't do this. Okay, and if you're taking too long to ship something, that's not micro. Once again, that's not micro. If you're taking too long to ship something, that's not micro. You need to be able to ship things quickly and test them all out. Okay, so thinking about Conway's law again, microservices work well with larger teams or organization. So if you're a startup with a small team, it kind of makes sense to go with a monolith. It's not a terrible idea, but you need to understand, how to set your boundaries, so that when your startup grows, you're able to scale it to microservices easily, right? So you want to keep that in mind while you're designing it. Monolith is not a terrible idea, but after a certain point, it is just terrible, right? So if you're a small team and it's very experimental, don't just start with microservices. Okay, because it's a pain. It's a real pain, and it works with uh bigger teams. Okay, and people who have experience. You need someone with experience to work there. You can try it out, you can test it out and all, but if you have something mission critical, maybe don't go with this. Try the monolith first. Always start with the design. Okay, start with the design, but assume that design is wrong. Okay, so this way you can iteratively update it. Okay, and that's how it should be. A lot of times it's like, oh, we have to really think about a design, because once we decide on that design, once you decide on an architecture, there's no going back. and a lot of the problem, that's actually what happens, a lot of times, we create an infrastructure and we are like just gonna stick with it, right? Because our product managers, our executives are not giving enough time to upgrade our process. So once again, is going back to communications. So one of the greatest disasters you have in microservices just is this API hell. All your services are calling each other, and it can have like very weird deadlocks. Like service one is calling service two is calling service three is calling service one, and now you are just in a cycle. So you can have real deadlocks here. So you want to be very careful with this. You want to make your microservices resilient, and you can use some resiliency like a buck circuit breaker pattern. But there's a talk by Netflix on how they achieved it using Chaos Monkey. So, take a look at that and understand how that works. Also, so microservices focus to a small thing very well. Okay, it's basically autonomous in nature. Okay, so let's get to like how do we design a microservice, right? So before we get to that, let's understand what a service is. So this is a talk by Jimmy Bogart. Okay, take a look. It's a great talk, and I just love how he has how he has described this. So I just without any shame, I just copy pasted and used it here. So what is a service? It is basically software that is owned, built, and run by an organization. It's responsible for holding, processing, and or distributing different kinds of information within the scope of system. It can be built, deployed, and run independently. It communicates with consumers and other services. It protects itself from unwanted access, and it handles failure conditions such that failures can lead to more information corruption. In a way, if I want to keep it in one word, it's autonomy. Okay, your services is autonomous in nature. Okay, your particular service, it only takes care of its own code, it only takes care of its own data, it doesn't affect anyone else. So that is how your services should be. And typically your organization, the small teams that you have will be will be the small teams will be dedicated to a particular service. Right, so that's how typically, that's basically how what a service is in a microservice. Now, let's imagine that you have a semantic search model. Okay, so let's say you're using this SBERT model and you're trying to you have created a machine learning model which uses semantic search. Semantic search is basically, let's say, HP laptops under the price of 3,000. So the machine learning model is able to detect like, okay, you're looking for the category laptops, the particular brand is HP, and the price is this. Okay, so that's nothing but your what do you say, a named entity detection. It's a normal NLP process, but anyway. So let's say you have this machine learning model, and typically this is probably how your architecture would be. Okay, so you have your machine learning model. Okay, and now you have these different services. You have like products, catalog, pricing, different content, and this example I've actually used from the same that Jimmy was talking about in his talk. So in here, you would think that, okay, I have a search model. Okay, I want to search, what are products, catalog, pricing I have. I got my, sentence, and now I want to detect based on this. You would think that, what, I'm just gonna, I'm gonna call my APIs to these products, to these catalog, to this pricing, okay, and get the information back in here. Okay, and then, I will return the search results. Okay, the problem is this is a lot of calls. Okay, your search model is calling your products and it's calling catalog, and your information is coming back, and you're gonna it's actually pretty complicated, because right now it seems simple, this image seems simple. What you have to understand is between these services, the product catalog, you might have 100 lines in between. Okay, going up and forth, data is going up and forth. And the reason why typically you would go with this model is because once again, when we go back to college, what we have studied is asset properties of data. It should be resilient, there should be no repetition in data. So you will have one single database, okay, where you have your products, your catalog, your pricing, everything. Okay, or you might have multiple, if you're, if these are also like small services, right? And you try to get that information from the database, you bring it back here, right? And then you use it. So, you're not having data duplication. So this is why you will go with this pattern. But you see the problem here, right? Your problem is that you have to call each of them. Okay, there's going to be a delay in there. Okay, when you get that information, and this is your search bar. Basically your search bar is taking this long to get the results back. Nobody's going to use your product anymore. So you see that, your model might be amazing, it might be state of the art, you're using SBIRD to do this, uh, but the problem is, because of your infrastructure, you have failed miserably, right? So how can you solve this? And that is, inverse it. Your dependencies on this, inverse your dependencies. Okay, and I would do something like this. And so the thing is, I want my search to be incredibly fast, right? Okay, it has to be fast. I need to get the information very quickly. I can't wait for these guys to give me the information. So what I'm going to do is like, so these services are there, okay, update all the data into, some database or some data store, which is very close to my search model. Now I will access this particular database. Okay. So now I don't need to call the products in, products for, okay, do you have HP? I don't need to do that. I have it in my database. Okay. So it's so much more faster that way, right? Now you might be asking, there is a problem here. You still have to transfer data. True, but which one are you going to do frequently? Are you going to search frequently, or is the data, getting updated in DB more frequently? Which one is it? So once again, you might get new products. Okay, you immediately update in database using some job. Okay, and that is it. It's not that high frequency or anything. Okay, maybe content is probably something, it's your website contents, or things can change extremely quickly, right? But still, your flow it's very linear. Okay, you get some, content, updates have come up. Okay, your catalog has been updated, push it into the DB. That's it. And your search model, it just doesn't care about it. Now you have that autonomy with you, right? Your search model only cares about this, right? And the rest is also there only, they only care about that, because before, if in the previous one, your products catalog, they all have their own APIs, they all have their own payloads and everything. The search model had to support all of them, which is just a pain, right? Now we don't care. Products, okay, I'm going to send it this way, fine, update in a database this way. You have more control here, right? And your search model can just take care of it. So, data duplication, not the end of the world. uh Also, so I'm going to speed things up. So how do you detect your, like, first thing you want to understand is, you're like, what is your service? Okay, there are two types of services. One is stateless, and which is basically, it doesn't contain any state. It just it gets a request, it runs, and is over. Okay, I just don't care, it's done, over. Okay, so if one of my nodes go down, I'm totally okay with that. Stateful, there are services that, it contains state. Okay, there is something happening, and then it gets propagated. So most of the time, you want to convert your stateful services to stateless. But if you can't avoid it, more effort goes into stateful. Stateless is much more easier. I only have 2 minutes. Oh, that sucks. Okay, so majority of the time, you're gonna have, like, you're gonna do something with event-driven architecture. Okay, so and most of the time you're gonna go with event notification. Okay, and how that pattern works is, your machine learning model, it gets a request. Okay, it takes about 10 minutes to process the information. Run your model. So your API can't wait for that, right? So what we're gonna do is just update using a queue. Okay, update, hey, this event is complete. Okay, and one of a UI or anything will collect that and just process it, right? I can share this one very quickly. And this is your typical, model. Sorry, this is your typical design in majority of the machine learning. You probably have come here to find a design so that you can just use it. But so this is one way of doing it. This is majority of the time, it looks like this. You have a UI, you have an API layer which handles all your business logic. There's a database connected to that, and then you have a queue where all your requests go through your queue. Your machine learning model gets, it picks them up, okay, it processes them, and it's scaled, separately using so this one will be something in Kubernetes or something like that, right? And as you're doing this, you update your notifications, and then you have background jobs or something which will update your both your database that your API is using and your data store that your machine learning model is using, right? So this is typically how a design looks like, but don't just follow this blindly, okay? Because it really depends on what it is. This is a huge matrix that I, it's typically very helpful. So, take a screenshot of it, but once it, oh, what's that? Oh, yeah. This is purely my personal opinions. And once again, this is not very complete in nature. Okay. So, typically, if you want instantaneous results, you want it to be instantaneous. Okay, you want to make your model small, you have to reduce your data, and you can see how complex it gets, right? And when it is a progress bar, you probably want to go with something event triggers or something, because the time takes up like that. And if it is queue, it's going to work with batches. So these are different speeds that basically your SLA. Okay, what are you promising, how fast it will be? And this on top will be like how big is your model and how big is the data as well. And you can see how complex it gets. And majority, if I like have like a gradient, I don't know how to do that. So basically, how much how close your teams have to work together. Okay, the top left, okay, the top left would be the most red zone, because your data scientists and data engineers and operations, they all have to work very closely. And as you go towards the bottom right, things they can work separated out, right? Because the requirements are very less, right? So this is a good reference point. Okay, it's not complete. I don't think it's coming, because this is just really generalized. But yeah, that's about it. So yep, we have exceeded time. All right, cool. Anyone has any questions? I'm sorry, rushing out at the end. I took too long in the middle. Will appreciate your complexity in engineering required. I think it's easy. Okay, okay. I had answered this. Sorry. It is. Can you explain, anonymous? It is getting so complex in nature. Do you think there's a scope for a holistic solution? I didn't fully understand the question. Hey, Amdad, can you draw a connection in data engineering to distributed systems to microservices? Data engineering to distributed systems to microservices. I'm not sure how, because microservices are, they are distributed systems, right? And I didn't fully understand that. Well, microservices are distributed systems. If you're asking like, if you're asking like how data engineer, how do we bring that up as well, updating your data and, making that also part of the microservice, is that what you're asking? How the data engineering process is also coming as part of the microservice architecture you have. So you're talking like, okay, how do you like, what is the, higher level of how everything is connecting together? Is that what you're asking? Okay, so it depends. So first of all, it depends on your data. A lot of times, once again, you don't want everything coming up together, because it's more difficult to maintain. So you're gonna have like different architectures, right? So your data engineering will have their own pipeline in place. Okay, sourcing data from different sources and bringing it in together, transforming and doing all kind of pre-processing before they give it to the machine learning model. right? So all that part, all that transformation and everything, they are typically done by a very separate pipeline. And that is, people use Spark, or they go, they write their scripts in Python or something, and it just happens a little more independently, and that's totally fine, right? That's totally fine. You don't want that connecting towards your their system which is running online, right? Because once again, you're bringing autonomy there. You don't want to put it in the same space, so this one will be separated up. Now the connection might be, if let's say your machine learning model has to get updated automatically and then like get deployed there. Okay, so the connection would be your data would be connected to a data store. Okay, and let's say if you're using serverless or something like that to trigger your model, okay, your model will be triggered by some let's say a storage trigger, right? So data has come in, or any form of trigger, doesn't really matter. uh, you trigger that, and then your machine learning model will start training on the new data. And if you don't have any more manual intervention in place, then you can directly deploy it. And for that, you could have something like AV deployment. Okay, so you'll have your old model and the new model, and traffic goes on both of them. And then slowly the new model can take over the old one. So it really depends on what your problem is, how you want to strategize it. There's no a single answer, right? It's not that direct. um any workflow you suggest for MLOps? Huh. So yeah, go with what you have. So if you're using GitHub or anything, use GitHub Actions. They are great. I personally use DVC for data. DVC is great. It's a amazing tool. I MLflow is also a very popular tool. I personally don't like it because I like, in my head, I'm someone who believes that these tools has to be external. They have to be third party. So I don't like putting it inside as part of my model. So it kind of gets annoying that way. So I'm not a huge fan of that. But I generally like DVC very much. It's very easy to use. It's a really good tool you can use. And also, oh, don't be afraid to use vendor solutions. Because majority of the time, your cloud vendor solutions, I mean, majority of the time, for example, let's say if I want to do a event-driven architecture, most of the time people will go with Kubernetes KEDA, right? And one of the strong, reasoning for that is that, oh, if I have to transfer my cloud to another cloud, it's so easy. But thing is, it's not, right? Because you did your due diligence, right? You did your homework and everything, and then you chose E2E cloud, right? E2E networks. You are not going to like, oh, I'm just gonna like, just throw a dice and select whichever cloud comes in. Then you have a real problem there. So don't be afraid to use your cloud infrastructure. Don't be afraid to use your cloud vendor. So instead of using KEDA, you can have like cloud. Let's say you're using. I know this example in AWS, but that's why I'm saying AWS. So AWS, you have a CloudWatch. Okay, so from that, your events can get triggered, and then you can scale it with the just a normal easy to you can scale them up, right? So don't be afraid to use your cloud solution, because most of the time they're very easy to use. Okay, because that's one of their attractive options, right? It's very easy to use, so all your configuration you don't need to care about, right? So try to use that. It's a good thing. And even let's say that you come to a point where you're changing your cloud, there's a lot of effort in it. Okay, it's not something you can just lift and shift and just put it there. There's going to be a lot of effort in it. There's going to be a lot of communication happening, because it's a huge change as an entire, not just an organization, maybe even an entire enterprise as well. So it's not going to be so easy. So if you're going with the concept like, oh, I need to use a solution which is not dependent to the vendor, you're missing out a lot of stuff. Okay, like Lambda functions, there's most of the cloud just takes care of it. So don't be afraid to use the vendors. So yeah, that's that. Yeah, data versioning, like I said, DVC is a very good option. When do we decide on using a microservice or in an ERP or distributed system? When do we decide when typically when your organization is getting a little bigger, it makes sense to go microservice. Okay. Or when your monolith is just getting very heavy to maintain, probably time to break it, right? So, always start with a design in place, start with a model that's, monolith that's okay. But, always keep in mind, we are going to constantly update this. Okay. Because that's what majority of the problem is. We think that, oh, I have to really think about my design because I can't change it later on. That's a wrong concept. Okay. And a lot of organizations also have the, people hire developers, okay, they hire a company to do their product, and then they plan on firing all of them because now they'll just take it. That's a wrong concept, because software is never over. It's never finished product. It needs constant maintenance, right? So it depends on your requirements and everything. Be careful. But the entire point with this one is that now you have an idea. Okay, these can be, their own separate services. Okay, so you design and create your boundaries that way. So that's how, you can decide, oh, it's time to break a micro. And when you do break, okay, and you eventually will, if you're done it properly well in the beginning, it can be easy. It will be an easy process. So that's that. And what is the need for shadow deployment? I'm not sure. Can you give an example, like how Uber does it as an example? See, that's also a wrong way of thinking. Okay, you don't want to compare with Netflix, Uber, and all these big companies, because the problem is these companies had a lot of money, a lot of resources, all invested in this. Okay, you probably don't. Okay, you probably don't have any of that, and I believe you're having in a startup, right? So you can't go with these kind of solutions. It's going to be incredibly, because they have gone through tons of iterations. They have spent so much money, and you can't just like okay, I'm just gonna like I'm just going to use whatever they used, right? Because it's not that simple. It's very, very difficult. So I mean, yes, so you can like gain inspiration from them, but don't try to do what they do, because they are going with very specific things. So once again, it is our mentality that to have a solution that works with everyone, right? The thing is, you really don't have. It really depends on your requirements, right? um any tools you suggest for orchestrate? Kubernetes, there are just so many out there. One of the most popular is Kubernetes. So it's good to stick to the popular choice, especially when it comes to this one. And the reason is that, it's because of community. Okay, if you pick up something which doesn't have enough community, you are probably gonna have a very hard time figuring, figuring issues. Um, so yeah, that's that. Give an example. Yeah, so you can take there's a lot of talks, and how Netflix has solved it, and how they have made a very resilient network. Okay, and how they implemented Chaos Monkey, and what they would do is they would like cut off multiple nodes, and their network would still hold. Okay, so take a look at these examples, but they are very, very specific use cases, right? So you can't really just use them for your own thing. Okay, get inspiration from them, but don't try to do that. uh, okay, yeah. So yeah, I mean, you have listed them, Apache Airflow, Luga, MLflow, DVC, the Ramnath. So you have basically listed out those. So, and in fact, these are the ones I also know, because these are the popular ones. And it kind of makes sense going with the popular ones, because these are like very complex solutions, and you need a community. You really need a community to move forward. Otherwise, it just becomes very difficult. Um, So yeah, sorry. Wo- Need for shadow deployment. I don't know if you need it, use it. I mean, shadow deployment is basically like, you just push it to production, okay, and users are just, they're just unaware of it. That's basically what that means, shadow deployment. Uh, you it depends, if you want to do it, do it. Like in our case, I would say that what we have, our team have been doing is sort of shadow deployment, because at times when we want to quickly fix bugs and stuff, we will just quickly, like, okay, we just put it in production and hope for the best, nothing breaks, because once again, you want to push, you want to push things very quickly. Okay, time is of the essence. You want to get things quickly, so you don't wait for the entire cycle. So that, but actual shadow deployment, where it is being used, is actually when you have hot fixes. Okay, when you have a hot fix, you have your machine, or any code. Okay, basically anything. You have a very quick hot fix. That it's very critical. You have to fix it, and it's a very small fix. It's a very, very small fix. Okay, you don't want to go through this entire cycle of. So typically, you will have three stages. You have your development, staging, and production. Right. First, you go to your development, you test everything, then it goes to staging, your QA engineer comes and tests everything, and then it goes to production. For a small hotfix, you don't need to do that. So that time, shadow deploy, it can be used there, right? You can silently just like deploy directly to production and quality and everywhere. Right. And that's totally fine. Okay. But you want to be careful with that sort of thing, because you really don't want to break production. So, be absolutely confident with your ability, I would say. So yeah, that is probably one of the needs of shadow deployment you can have. Yeah, I haven't personally done something. I mean, other than what I just shared, I haven't done anything, any other use case. So I can't answer that. Uh, Anything? Oh yeah, the anonymous attendee. If you can describe what this holistic, so I didn't quite understand the question. So if you can ask it again, with more details, probably I can try again. Mm, okay. Yeah, and I hope that was helpful. Yeah, Ramnath, I think you got your options right there. So I don't know. I don't know anything else to add there. uh, yeah, and but all the best for your startup as well. Do let us know, what you're working on. That would be pretty cool. We wish you all the best. Yeah. Sagar, with the shadow deployment answer, is that what you were looking for? Or maybe I have understood shadow deployment? No, I think that's what that is. So, anything else? I guess I'm not seeing anything. So yeah, hey Aditya, hey.
Hi, sir. Thank you for the session. It was very insightful.
All right, yeah, I hope so too. Or you're just
Yes.
being nice to me. Cool.
And thanks to everyone for attending the session. I hope everyone had an excellent time and is leaving with valuable insight. Thank you, sir, for sharing your thoughts and knowledge. Also,
Sure.
I would like to let everyone know that NVIDIA A100 is available on E2V Cloud, and you can contact us for your free trial. And E2V Cloud will be having another webinar on hacking and securing Kubernetes cluster. I see a lot of people here who are interested about Kubernetes. So on 19th of January, we'll be having that webinar and invites will be sent to all. Hope to see all of you there. Thank you, sir.
Dope, dope. All right, everyone. Thanks. I had a great time. Thanks, everyone. Happy New Year. Have a good one this year. Bye.
Bye, sir. Thank you. Happy New Year
Thank you.
to you too.